Hey guys, so this is 2.7 inverse function. This is the last section of the chapter 2. So as we discussed in the class, inverse function basically means that your x and y values are inverse or the switched. It's not the reciprocal, so do not get the idea of flipping your number. It has nothing to do with it. It basically means that your input, which is the x value, becomes the output of the inverse function, and the output of your original function becomes the input of the inverse function. So in a simpler way, if for the usual f at x, usually f at x or x goes to, let's say, y, but now the direction now has been inversed. Okay, so we put the y and try to get the x. That actually is the basic concept of the inverse function. So here the notation is always f at f negative 1 at x, but this negative 1 doesn't mean that you are taking the reciprocal of it or you're doing the power of negative 1. Has nothing to do with it. Remember, f at x doesn't mean that f times x, it's just a notation. So in this case, that negative 1 there is also just a part of the notation. Has nothing to do with algebra. Okay, so please do not get confused with it. So as I said, your x and y values are switched in order for you to get the inverse function. So in other words, your original functions x and y becomes actually y comma x for the inverse function. Okay, that means that your domain becomes the range, and then range becomes the domain of the inverse function from the original function. So if I had this in the original function, the 1 comma 2, and if I want to come up with the inverse function of this function, then this 1 comma 2 becomes 2 comma 1. It's basically just switching the values, right? And same thing for negative 4 comma 2. So the original function is negative 4 comma 2 becomes 2 comma negative 4 if you get the inverse function of it, and then same thing for the last. So it's a very simple concept. However, if you're confused, it may just get very nasty. Okay, so do not be confused. It's just that your x and y values are switched. Okay, that's the inverse. Now, so then how do we know the inverse function's equation from the original one? So as I said, the x and y values are switched, correct? So in this case, we're going to do the same thing, that we're going to switch the x and y. So then here we have the y here and then the x there. So all we have to do is just rewrite, but instead of y equals, then it becomes now x equals 3y minus 4. I just switch the position of the x and y. Then you try to solve for the y again, so that at the end it becomes y equals something. However, even though they are both equals to y, they are not the same functions. Okay, don't forget they are not the same functions. It's just the notation that we're using here. So I will put it this way: f at x equals y equals 3x minus 4 to begin with, and then we switch the x and y to find what the f at negative 1x, which is the inverse of f at x, is. Then x equals 3y minus 4 by switching x and y, and we try to solve for the y. So it will be x plus 4 equals 3y, and then we divide everything by 3. So then this eventually becomes y equals x plus 4 over 3. So your inverse function f at negative 1x actually then becomes x plus 4 over 3. Or you can say, yeah, you can say that. You can simply just say that easily. Okay. Now then let's do the second example. In this case, we're not dealing with a simple equation like the first example, which was the linear. This is a quadratic. The same thing though. The whole concept is the same. So you change the y to the x and then change the x to the y, and you try to solve for the y. So we subtract 4 on both sides. So we have then x minus 4 equals 3y squared. Then we have to divide it by 3. So then this becomes then x minus 4 over 3 equals y squared. Now, as everybody knows, to get rid of the square, we have to take the square root of it. So it will be square root of x minus 4 over 3 equals y. But remember this, when you're taking the square root of something, you always have to put plus minus. Okay? You always have to put plus minus. So as long as you remember this, then it should be okay. So your inverse function is then plus minus square root of x minus 4 over 3. Then let's do the square root one then. Then how does that work? So same thing, change the y to the x and x to the y, and we try to solve it. So then in this case, I'm going to subtract 2. Subtract the 2 here too. So then x minus 2 equals square root of y minus 4. Now, the question is, how do we get rid of the square root? Well, the simplest thing is we square all of it, right? So then the square root of y minus 4 being squared, the square will cancel out the square root. Then we have x minus 2 squared equals y minus 4. Then you add 4 to each, so this becomes the x minus 2 squared plus 4 equals y. So our f inverse function is then x minus 2 squared plus 4. Are we okay with this? So hopefully this helps you. Now then you may want to ask me, but this one is just the top portion of our function. So that means that this one should be only the left side of it. Now that means we only have to care about the left side. So we have to set the restriction here that x has to be less than or equal to 2. Now, the reason is actually very simple. If you think of it, right? If you think of it, the reason is very simple. I'm going to actually use some extra space here. The y equals square root of x minus 4 plus 2 looks like this. And this point is at 4 comma 2. As you can see, it was the transformation from this to x minus 4 plus 2. So this minus 4 means that you're moving to the right by 4, and this 2 means that vertically translated up by 2. So instead of starting at 0 comma 0, it's now starting at 4 comma 2. Now if I then have the inverse function of it, this 4 comma 2 actually then becomes 2 comma 4. And if you actually look at this, the vertex of it is, we know that it's 2 comma 4. Now then you're going to ask me, how am I supposed to know whether this is the right side or the left side? Well, if you think of it, it's the y equals x line that it actually rotates around. So if you take a look at it, it actually then changes. So be really careful with those. Okay, be really careful with those, so that in this case, if I actually show you in terms of the drawing, I'm going to show you in terms of the drawing. So if I have then 1, 2, 3, 4, and then 1, 2, so it will be here and then going this way. And then if I draw that y equals x line, the rotation line, then if I rotate this along, so let's see what happens. So then the 2 actually becomes here. Now this one becomes there, and then this one becomes here. So it actually looks like this. So be really careful, okay? So be really careful that now your x value has to be greater than or equal to 2, okay? Because you're actually looking at only this one. So you have to have the restriction here. So restriction there, okay? Now make sure you understand this part. Now, then having said that, then we just need to find the domain and the range of it. Okay, so we just need to find the domain and the range of it. It's not that difficult to find the domain and the range of it. So I'm just going to rewrite here again. Something had gone wrong with the file. That's why it's happening here. So for the first one, the domain and range. Well, remember, the domain and range of the inverse is the range and domain of the original. So in other words, the domain and range of the original is the range and domain of the inverse. So you basically switch it. So the easiest way is to find the domain and the range of the original and then switch them. So what was the domain of the original? Well, domain of the original is x such that x is an element of the real number. And then range also was real number. So this was the original, right? This was the original. But remember, for the domain and the range of the inverse, you basically switch these two. So for the inverse, this then becomes range as the y such that y is an element of real number, and then domain as x such that x is an element of real number. Now then for the second example, same thing. If you look at this one, this actually looks like a parabola with the vertex at 0, 4, right? So your domain, so for the original, your domain is at x such that x is a part of a real number. There's no restrictions to it. But for the range, y such that y is an element of real number, but y has to be greater than or equal to 4, since the vertex is at 0, 4, and it goes up this way. Now, then the question is, what is the inverse? Well, remember, inverse, we simply switch the x and y's. So your range now is y such that y is an element of real number, and then domain as x such that x is an element of real number, but x is now greater than or equal to 4. So hopefully you see the relationship here, okay? And then the last one, which is kind of tricky one. So the last one's original domain is that x such that x is a part of a real number, but x has to be greater than or equal to 4, right? Because what's inside of the square root sign must be greater than 0. So anything that is less than 4 for the x value, it will give you the negative number inside of the square root. Therefore, it's not possible. Now, then the range is that y is a part of the real number, but y has to be greater than or equal to 2. And we know that because this function starts from 4, 2. And it basically just goes up to the right, so nothing actually below. In a simpler way, the lowest value that square root can become is 0. So 0 plus 2 is 2. That's why y has to be equal to or greater than 2. Then what is my domain? Sorry, what is my inverse? So the inverse then becomes just a range that y such that y is an element of real number, and y has to be greater than or equal to 4. And then the domain is then x such that x is a part of a real number, and x is greater than or equal to 2. Now remember the restriction that we actually came up with before? It actually is stated. So please be careful when you are graphing them, okay? Graph them very carefully. I would recommend that you come up with the equation, then come up with the range and domain, and follow the range and domain as you draw them, okay? So that was quite okay. Then the next page is basically just graphing it, and graphing actually is quite easy to do. How we do it, we don't even need to actually come up with the equation. All we have to do is just come up with the table of values, and then we switch the x and y values and graph them again. So in this case, I have 0, 0. So I have 0 and then 0 for x and y for the original. And then I have 1, 1. I have 2, 4. I have 3, 9. So I'm just going to stop there. Now for the inverse then, the x and y switches, right? So from the original 0, 0 switches, doesn't really make any differences, same thing. But the inverse then switches to 4, 2, and then 9, 3. Now just to make sure, I'm going to actually do the negative numbers as well. So it will be negative 1 and 1, negative 2 and 4, and negative 3 and 9 still. But in this case, we have to switch it, so it will be 1 and negative 1, 4 and negative 2, and 9 and negative 3. So these are the inverse function's coordinates, right? So these are inverse functions coordinate. So that means we start from 1, 0, 0, 1, 1, and then 4, 2, then 1, negative 1, and then 4, negative 2 somewhere down here. So our inverse graph actually looks like this. Okay, so that's how we can easily do rather than trying to come up with the equation of it and it's going to be a lot more difficult to do. Same thing over there. So then how do I do it? Again, your original one was at 0, 0, right? This is, let's say, the original. And then 1, 1, and then 4, 2, and then 9, 3. Now we cannot go into the negative number because we don't have any negative number in the x value of the square root of x function. So the inverse then in this case is we switch the x and y value from the original. So it will be this way. So the new one then will be, I'm going to use red since this one uses the green dot. So the new one will be at 0, 0, 1, 1, 2, 4, and 3, 9 somewhere up there. So it actually looks like that. Okay. So hopefully you're actually getting this. So again, all you have to do is make the table of values for the given function or given graph, and then switch the x and y values. Now, then what about this one? This is not even a function. Doesn't really matter. So for the originals x and y, I'm just going to use these points. Okay, I'm just going to use these turning points. That's all I need. So this one is at negative 4, 1, and the next one is at negative 2, 5, and then 1, negative 2, then 4, negative 2, and 1, 2, 3, 4, 5, 5, 3. All I have to do then is for the inverse, switch the x and y values. It will be 1, negative 4, 5, negative 2, negative 2, 1, negative 2, 4, and then 3, 5. So again, as you can see, I switch the order of x and y for the inverse from the original. So all I have to do is then I just have to plot them. So add 1, and then it becomes at negative 4. At 1, 2, 3, 4, 5, we have a negative 2. And then when negative 2, we have at 1. And then, where are we? Negative 2 and 1, and then negative 2, and then 4. Oop, that's not 4. This is 4. And then 3, and then 5. So 3, and then 5. So what you have to remember is you have to remember the order of the points. So we started off with this one, and then we went to this point, right? 5, negative 2. Then we went to this one that way. So it is critical for you to actually follow the order. Now, just to show you, I just actually want to show you this. If I draw y equals x line, if you actually compare the black line with the blue line, it's the mirror image on the y equals x line. So hopefully you understand this. Hopefully this is helpful to you. Okay, so if you have any questions, let me know during the math help hours, then we'll try to get through. Okay, all right, bye.